we come up with the time series in forecasting that we call the naive forecast. The forecast for any period equal to the previous period actual value. The native forecast, this is for use to simple to use. It's virtually no cost, quick and easy to prepare. Data analysis is no existent and easily understandable. The naive forecast is the easy way to handle the data. Cannot provide a higher accuracy. Can be standard for accuracy. Look at the example. The naive forecast ignore on data point in the time series except the last one. That means the forecast equal to the last value. Look at the example. Month by month sale in the 1,000 over the interval 6 months, 17, 25, 24, 26, 30, and 38. So the forecast for the July, this means in the last value, this means an equal 28. For the time series forecasting in averaging, this technique works best with the series trend to vary about an average. Averaging techniques smooth variation in the data. They can handle step changes or gradual changes in the level of the series. Technique, we have the technique in averaging that uses simple moving average, weighted moving average, and exponential smoothing. For the simple moving average, we use the average over the given number of the time period that is updated by replacing the data in the onset period with that is the most recent period. The formula shows that if subscript 3 equal to the actual sale in the period of t-1 plus actual sale in the period t-2 plus together to the number of periods in the moving average over the n. N this means number of the period in the moving average. Look at the example this. Forecast demand based on the 3 and 9 week simple moving average. On the Excel graph, 167, this is come from the 800 plus 1,400 and 1,000 over the 3. Similarly, for the Excel on the week 10, 367 equal to the sum of the week 1 to the week 10 over by 9. Simple moving average. As the new data become available, the forecast is updated by adding the newest value and dropping the oldest, and then be recomputing the average. The number of data points included in the average determine the model's sensitivity. Fewer data points used, more responsive. More data point used is we call the less responsive. Another method in the forecasting we call the weighted moving average. The most recent value in the time series are given more weight in computing a forecast. The choice of weight we call W is somewhat arbitrary. Sum of the weights must equal 1. The equation is provide you to find the FT. It looks like a moving average, but in weighted moving average, we time the WT, that is the weighted for the period corresponding to the actual value for the periods at that T. For the weighting move average, look at the example for computing moving the average. We have computed the weighted moving average using the weight of 0.4 for the most recent period, 0.3 for the next most recent, and the last is 0.2 for the next, and 0.1 for the next. We find the forecast for the period 6 equal to, if T equal to weight, that means F6 equal to 1.4 times the 41 plus 1.3 times 40 plus 1.2 times 43 plus 0.1 times 40 is equal to 41 units used in the mathematics simple. For the last one, the exponential exploding, the forecast ft is equal to the forecast t plus 1 plus the alpha times the actual demand minus forecast the t plus 1. Weighted averaging methods based on the previous forecast plus a percentage of the forecasted error. The difference of A and F is the error term. Alpha is smoothing constant. This is range is bigger than 0 and less than and equal 1. The example 3 shows how to calculate the forecast using the exponential smoothing. For the f of 2, that means the period 2, we call the f forecast equal to 42, but for the period 3, use the formula, that's period that I show you. The outcome is 41.8, and so on procedure for the period 12. The outcome is 41.73. Use an alpha 0.1, and likewise for the 0.4 procedure look like the same, but you have to change the alpha. This is called the outcome for the column of the ft for the alpha equal to 0.4. For the picking of smooth constant, you have to know that for the actual for alpha 0.4 and 0.1 in plotting for the period and demand, you have to choose which one that is corresponding to the actual.